Now you are getting?
Sir, now it is okay, sir. Now it is okay.
Fine. Okay. Thank you, sir. Just quickly, I will go through next half an hour. I have not seen who is there. Thank you very much, sir, for giving these opportunities to interact with all the people from TNIU. It's indeed a pleasure for me to interact with you. So some students are there.
Yes, sir. Students are there, sir. Sir, both PG and PhD students are watching, sir.
They are watching PhD students. Okay, okay. So
PG and
so that now
PhD.
I will change tune to the audience. Okay. So I will focus it on the PG and PhD students. That will be better. Thank you very much. Dear students of MSc and PhD of TNIU and all the staff members of TNIU and all the members, those who are joined online. Just I quickly give some journey of land resource assessment, how we have done in India and globally, and also with respect to agronomy discipline or natural resource management, how it is useful. So the intention is not to give any lecture, regular lecture that you receive it from your teacher or educational point of view. Neither it is the what is the advances which is available in the field. So my intention is just to give you a give a mind opening exercise so that you will think how we have the journey was using these land resources, and also what are the opportunities available in India and abroad, so that it is useful for you. So like this, I will change my content. The relevance of land resource assessment is at personal, organizational, and the country level. At the country level, use of you all know that the use of land resources is very, very vital for improvement. When our country became independent in 47, we were only starving mouth and hungry fields are available, and our scientific advancement with reference to the agriculture was very minimal, because our agriculture was totally transformed to supply as a raw material to the colonial power. So that was the conditions when we started this agriculture research. And incidentally, TNA is one of the pioneering institutions started much before our independence. So we had a specific requirement for the country to give a to meet our food resources from the limited land resources. We cannot bring more land into the resource, but only we have to intensify. And also we have organizational commitments. So we have very, very limited organization working at looking at this land as a resources. So we should develop organization, and also we should gather scientific evidence how regarding how we will use these land resources for improving food productions. And personally, we need to improve these human resources. At that time, even the BS agriculture was students or faculty available was very limited. Only people from botany and other sister divisions, they were teaching agriculture, and no specialization was not available, and also the trained manpower was limited. So this was the situations when we started our land resource survey in India. Thankfully, we have grown all our policymakers and the planners of this country, great country. At this juncture, we have to remember several people, those who have pioneered in the agriculture research in India, and including the state of Tamil Nadu. A lot of people have worked on this. So we faced a lot of challenges later on: the atmosphere, geosphere, and also hydrosphere, and also the land has to interact with all these surrounding system to improve the productivity. When you go for intensification, just we discussed, it will lead to degradations and also greenhouse gas emissions and other resources. It polluted our hydrosphere and also geosphere with reference to nutrient management and also water resources. Then land degradations was the issues when we go for after green evaluation. So we have to do some kind of exercise how to assess these resources, particularly land resource. I mean land resource, it includes everything. So these are the pioneers of land resource assessment in the country. Mostly we have to remember Dr. Velayudham also from Tamil Nadu, who has contributed immensely in improving Shagal. He is also a wonderful contribution. And similarly, we have lot of people from TNA also. They have contributed to prepare land resource inventory for the state as well in different locations. The circumstances now have changed. There is a resource, particularly land, I mean, soil, water, microclimate, crop, socioeconomic, the income, employment, productions, and also productivity, and different people, different needs, different food habit has to be addressed. Then the environmental issues like ecosystem services, land degradation, other climate change has cropped up. So this is the changing circumstances under which we have to do it. Land, I means that it is a delineable area encompassing all attributes of Earth biosphere immediately above and below. So this is a popular definitions by Ian. All the students, you should understand what is land. So when you look at any of the topic other than your class, particularly your class or textbook, I request when you come across any of the terms which are used in agronomy, soil science, or any natural resource, you should be very critical of what it means, that how to define it, because all your research outcome, all your focus, or if you write paper also, it depends on how you define it. So defining a particular term or terminology is very, very critical to set the agenda. If we are not understood what you mean by land, our entire research will go waste. And finally, when you land up in some international institution or national level, or when you face any critical interview during your critical time, this understanding the definition, particularly the basics of agronomy and soil science, relies on the definition and how you understand the basic process. So this is very, very critical for you. This my words, take it. If you are very clear, your views and the outlook will be very different than others. So this gives you very some kind of edge over other people. That's why don't hesitate to understand what it is. That's what your basic course maybe taught differently, but internationally, how each and every terminology is defined is very important for you. That set the agenda for you in a future course. So you understand this. Then the term land resource, we know physical, biochemical, environmental infrastructure, which is a natural unit, and also surface and below surface micro environment. Also we have land resource, this is included. So the evaluation of land resource assessment comes like this. We have to define this, then after defining, how we will put into use, productive use. That is what the challenge is before us after our immediate independent. Then globally the soil survey was the idea was mooted by Milton Whitney to have use this land for productive purpose and go for intensification, and also understand where is the research gap, so that we will improve the improved productivity. So when you use any technique, either fertilizer, irrigation management, any other agronomic practices, improved seeds and other technique, green evolution technique, if you are not understand the potential of the land, then something we have beginning with your production process, we are beginning a new kind of problem. So that we have to understand. So if you don't know the potential of the land, that we are going to use it, and we are creating a problem. That's what happened in many regions of across India, where the green revolutions was introduced. So green revolution, when we begin, we should also understand what is the productivity and potential of the land. Land includes soil, the microenvironment, water resource, then the methodology, then also the microbiome or biological system, which is just above and below ground. So entire things includes in your land. So that has to be surveyed so that we can use their land resource judiciously for our purpose. So that is how internationally they have started the program first in USA. So this, there is a natural system of land resource assessment. Our forefathers also knows this, how to use the land. Then Dokuchev and other genetic system has started in Russia. Then early attempts were made in Europe to understand this land resource potential in line with the development of scientific approaches and methodologies in other disciplines. Then USDA system has come with a very comprehensive system of soil classification that you all know. Also, the land resource assessment has started. Along with this, people have started issuing soil resource assessment data to the individual farmer, and also people started giving fertilizer recommendation based on this land resource assessment. In Indian system, you all know, from the beginning of our civilization, particularly Tamil Nadu is known for water management. We have Grand Anakat is built. This is a testimony for our skill and knowledge and the way we have used our resources, available resources for cultivation purpose, agriculture purpose. It is as old as our beginning of the history and civilization. It goes simultaneously. So we have started with the scientific management of available water resource, and the potential lands were surveyed, and those areas where it is fit for intensive cultivation has been used for irrigation purpose. Otherwise, it's mostly rainfed system. So this is how our Indian system also evolved along with the demand and increasing population. Now come to the journey, how we have come after independence. One is tools and method of soil survey has changed. We have started with the manual survey with Kurfi and Auger. Now digging a profile. Now it has been changed. Now the classification system. Now we are adapting international system. We call it USDA system of classification. And India we have our own system like we have potential land, irrigated land, and also unirrigated rainfed system. Also we have other generic system of classification like alluvial soil, like red soil, black soil. These are all some system. It is not a generic system. Then land use planning we have initiated to use our land in a potential way so that we can feed the people. The purpose is to meet the food security. So that's what our convergence point. So all the discipline have converged the one agenda, that is providing food security to the country by utilizing judiciously the resources. That is why the land use planning has linked all the disciplines. Then crop suitability evaluation, particularly which crop is suitable for in which region or land, and also identifications of farmer based on his economic and social profile. To before we suggest any crop or cropping system, that you can see in the Western Ghats region, you will go for tuber based system, and in Tamil Nadu you have all the irrigation command area, irrigated crop like rice based system, sugarcane based system. And earlier we have groundwater irrigation for particularly commercial crop like cotton based system. They were very popular since last 50 years or so. Now the system has been changed because not only your land resource potential based on land resource degradation, and also groundwater availability, and also irrigation system. Now slowly we are shifting towards more efficient crop and cropping system, and also how to put our resources into potential use, since land has been diverted for some other alternative purpose. That's very important. So this is what we have done. And earlier already we have published the soil map of India in 250,000 scale. So but this land resource information and putting into productive use is now getting a change, tremendous change, because what is the spatial distributions of land with different potential or constraint has come into being, because more information has come, more information is needed to go for a targeted developmental programs. So to go for a targeted developmental programs or targeting a farmers or identification of hotspot area, because in India or even your take a state of Tamil Nadu, your problem is not uniformly distributed production problem, and is it not? So today also we heard that the coconut has some problem. So these our your officials are busy with this. This coconut is specific to a particular region or a block. So where there is a large scale problem has occurred. So your problem is a specific regional specific. The scale is a matter. Then what other land uses and appropriate for each district has come. Now government of India is mooting the concept of one district, one product. Now you have to think how it is possible or how we can go about it, because one district, one product. If you go, say example Coimbatore district, which is the major or predominant crops, but your land resources are not, whether it is supportive or not, that we have to see. So when you go for a normal cultivation, it is different. When you go for a commercial based cultivation, so one district has to specialize only one crop, like coconut in one district. Now your land resources has to be channelized to support this crop and industrial activity, that we are moving towards a commercial cultivation. Also we are channelizing or diverting our resources to support the industrial based cropping system. So this is the talking point as of now, that you have to understand. Then physically possible and socially relevant, that we have to understand. Then what adverse impact it will associated with kind of land use, because when you go for industrial based crops like what you all know popularly, all my colleagues mostly sitting there as professor and assistant professor, they will understand. During our studies in southern part of India, where Tamil Nadu, where you have large scale cultivation of cotton. Now you cannot find such a large scale cultivation of cotton. Maybe because of pest and disease, maybe because of labor shortage, or cultivation cost of cultivation has increased, and also farmers could not afford it. Still, it is cotton is remunerative, but cotton cultivation is remunerative or not. That also depends on how we use these land resources for a particular crops like commercial crop. And second crop, you take a sugarcane, a lot of problems are there, industrial problems are there, lot of pollutions are there, groundwater is depleting, and the potassium use in sugarcane, particularly banana and reachability, is increasing, but the cost is also increasing because in the last 50 years or so, we know that we have to use this land for commercial cultivation, these resources, but we have not done enough on fertilizer front. We have done good on water management, we have done good on land use, but we have not done good on fertilizer use because most of our fertilizer, phosphatic and potassic fertilizers are still imported. So when you go for a commercial scale cultivation, one district, one product, or land resource based cultivation, intensification, so we have addressed all, but fertilizers front still we have to address because potassium consumption for sugarcane and banana is very huge. That led to a large loss of our exchequer foreign exchange currency. Now India is paying something around 1.4 lakh crore for subsidy alone, in which almost 40% is goes as an import subsidy, particularly for DAP and potassic fertilizer. This is the kind of situation is there for any student of agronomy, soils and natural resource management working in nano fertilizer. So this is a good area of research. You should understand the chemistry and use efficiency. And if you are coming out with any new product, new efficiency, improving by way of use efficiency, agronomic efficiency, your research is most welcome at national level because you are addressing reducing the import subsidy. That is what government of India is looking at, and you should work on this aspect. Think of it, that is a good area of research in the future. Then coming out to input and management changes which are necessary because we want to minimize adverse effect. Particularly now entire globally, we are talking about sustainability, climate change. So your agronomic practices, land resource assessment also has to address the global changes. So that is what I want to focus. So we have prepared agroecological regions, which is based on soil, bioclimate, physiography, then length of growing period. Now from 20 agroecological region, 60 agroeco sub-regions we have divided. This is something specific to a region because but still we have to address whether these agronomic practices at field level is same for all the 6 agroeco regions, or cropping system is same, or what about this microclimate, particularly root soil interaction which is taking place will be different in microclimate. So still there is a scope to improve our research and land resource assessment because we have come from national level down to regional, state and regional level, then district level. Now we have to move towards a micro and climatic level so that we can precisely use these resources. That's the idea. So this is what we have done our path. You have seen that Virudhunagar district, you prepared the soil map. Based on this, we prepare land capability, irrigation capability. Then we go for recommendations of crop and cropping system, diversifications also. Now, new kind of problem and techniques have come that we have to do it. Now, laboratory, think of laboratory analysis. So earlier days, some 20 years before, we have to go for wet method of analysis, laboratory techniques are there. Now we have shifted to instrumentation. Now it has become non-invasive type, that is without disturbing the soil or crop, but we have to collect the data. So that is what now I have seen Nagarajan how you have done. Lot of for sensor based, lot of data are you collected using spectral analysis. Remote sensing is one of the very good tool or platform to observe this data, particularly for soil and crop properties. Then ground penetration radar has come to collect the data without disturbing the soil so that we can cover large area in a quick succession, and the manpower and money required will be reduced. Now then again I could see some of you has used in vertical electrical sounding technique by which particularly this is very relevant for coastal area. This VES helps us to know what are the different layers below the surface and how it is stratified. This stratification and salinity below the surface particularly coastal area, will tell us how the front area of groundwater versus your salinity interacts. That will give you some kind of idea. Without going for a tedious survey and understanding, we can go for VES based survey so that we will understand how this groundwater is affected with salinity, how it has been interacting with the saline water, particularly seawater intrusion in the coastal area. Because in the coming days, climate change is going to stay, and because of climate change, seawater intrusion is imminent, and seawater surges occurs. Thus, recently you have seen the climate and also the frequent cyclone which comes in coastal areas of Tamil Nadu and the coastal areas of India. As frequency is increased, then intensity is increased. Because of this, not only flooding and also sea surges also bound to occur. So under such situation, understanding the groundwater mixing with the saline water, that we have to understand. This kind of analysis, this is the feature that we have to work on. Similarly, the data collection also gone tremendous changes during this more than 50 years after independence. Earlier it was field survey manual, then we used aerial photographs, then comes the remote sensing, then it went to multispectral remote sensing. Now India is also pioneer in launching the satellite multispectral remote sensing, which gives not only the color picture, but also we can observe the Earth surface in different spectra, starting from less than a meter to more than a meter, and also in multiple spectrum gives you different conditions of the crop and soil, which helps us to assess in a quick succession. Earlier we used remote sensing data previous years or time series. Now we have to use a real-time data. So that's where we have to go in the next time to control pest and diseases, understand the nutrient status and also deficiency symptom. We have to go for multispectral data in the coming years. It should be operationalized. Then hyperspectral data, very minutely we will observe, we can interact and collect the information. But the data is limited to a small area like 25 to 40 or 50 kilometer only. We cannot cover the entire country in a quick succession. Now then comes the drone technology. Drones are now into stay into your research applications. We can develop different cameras or sensors which can be mounted into the drones. Then we can collect the information. Maybe this is going to be not only research or use, but also one of the good service providing area for the students to come. So if you use these drones, particularly for survey purpose or monitoring purpose, you can be advising very apt and quickly to the farmers to avoid some kind of occurrence of pest and disease, nutrient deficiency, soil watcher management, and also other weed infestation also. So there is a tremendous scope for drone applications in land resource assessment, and now has become country level to farmer centric. Now every farmer has want information. Now because of advent of this commercial scale agriculture and also issue of soil health called field wise, now we have to provide a doorstep information. That it means farmer centric information and also landscape centric information. So if our country is moving towards landscape centric, farmer centric information to improve the agriculture or precise management. Precision management, not only a resource, land or land resource, and also agriculture point of view. So if this technique is linked with the social profile data, district level data in a spatial framework, you know in which area what is the land use and the size, land holding. So maybe you will understand the requirement of largest farmer as well as a small or marginal farmer is different. So if you are able to identify spatially marginal farmer where they are located, where the high income group, large farmers is located, big farmer is located, your technology applications will be very quick and input applications will be very efficient. So that is what we are moving towards in the coming days with the spatial application. And similarly, mapping of land resources also gone a tremendous thing. Earlier it was mental or personal. It is mostly of indigenous technical knowledge. The knowledge of land resource management or agronomic practice, water management, all comes from your forefathers. From generation to generation, it has been transferred. Unluckily, we have not put into records how our land and land resources has been used in our country. Very few records are there. Then comes the cartographic applications. Then computer with the advent of GIS has revolutionized the use of land resource. Then comes the physiographic analysis and multi-criteria analysis. With the advent of multispectral remote sensing GIS, we are able to overlay different layers and be able to derive a system or decision support system. That is why we have started with in our country. Then comes digital soil mapping, digital elevation model. So now we are representing the entire surface in a digital framework, which helps us to develop models, developmental models, synthesize, analysis, particularly for environmental impact assessment, groundwater impact, and also environmental impact, climate change impact. All are possible because of your digital elevations model. Then geostatistical tools. See, example simply, we cannot map everything which are below the surface. Say example, if salinity is there, salinity is not always visible, not a white encrustation is available to map it, but the salinity definitely will have impact on the crop. So by observing the crop parameter, particularly how succulent it is, how it is different from a normally grown crop. Say example, a crop grown in saline soil as well as a normal soil is different. The reflectance spectra on red and green regions will be different. So by using this and developing an index, we can know what lies below the surface. So this is called something correlating. So you are correlating one visible feature or measurable feature with unmeasurable feature below the surface, so that we can use the statistical tool like kriging, co-kriging, and error modeling. So these kind of new statistical tools have come using to measurable property to not unmeasurable property or unknown property. We can link it. Then we can go for large scale applications of land resource utilization and precise utilization. So that is the advantage of it. Now comes the fuzzy logic, how we are going to map our land and land resources, because it's keep changing. It is not very accurate, so that you can use the fuzzy logic wherever you have ambiguity is there. So that helps different applications. Now we are in the era of artificial intelligence and machine language. So how this machine language and artificial intelligence can be used a precise management and mapping of our land resources all, and also our management. Say example, simple a weed management. You take a weed management when you have a good artificial intelligence mounted machines are there. It detects all kind of weeds, and it gives a very precise applications and removal of weed. No need to go for manual because your labor are coming down. And similarly, it's very difficult. Some people says that manually to do it, it's very difficult to identify different kinds of weed. Artificial intelligence can be used to, instead of identifying the weed, you can identify the crop, then you can eliminate the weed. So alternate identification, then you can eliminate. So these are the different kind of use which are available now. Then these are all the new development globally is taking place, like carbon credit, carbon sequestration trading has come. Then poverty elevation program that is has come. So this changing socio-economic profile you have to keep in mind before you do it. Then the future, your ICT, IoT, and iOS tools are there, different operating system, handheld system people want. Then client-based approach is there. People are able to afford like commercial. Like if you take coconut or groundnut, it's almost a commercial crop. Then people are going for contract farming. So agronomy has to go a tremendous change to address to the contract farming demands, so that we have to go for high-tech management of the system because of participation of private enterprise and entrepreneur into the system. So other changing like climate change that we have discussed, food security, sustainability. Now we have to go for nature positive, then stakeholder approach, and changing socio-political. So this is what we have to understand, nature positiveness. Then research has to go a tremendous change. From search to research we have to go. Then evaluation to, we have to build a hypothesis which will suit to our need, and we have to identify the research gap that we have to address, because there is a participation, private participation into this research. Not only a government agencies, private participation, or even farmers also, they are interested to understand what is going on in that land because of coming up of contract farming. Then the national priorities are changing, the regional priorities are changing. Then the basic science application is also changing. This we have to understand. So this is how we have changed our ICR and NAR system. We are focusing in on climate change impact, digital soil mapping, and land degradation neutrality, and village level application, farmer centric applications. Then we have to go for now we are going for carbon crediting as well. So this is the changing situation that we have put it, and we have to align with always the government perspective so that we are remain relevant into our research perspective. Under Indian perspective, we have technology, but we have to connect to the user. So it is not the job of government agencies alone, but we have to client specific research. We have to do it, particularly for land based applications. How now? Let us think of the journey, how it should be, particularly for agronomic practices. It should reveal the transition from rudimentary to labor intensive method to technology driven precision agriculture. Basically, it should move on in the coming years. And also the journey of land resource management, particularly agronomic management of land, largely characterized by the use of satellite based technology, drone technology, that is space platform, rather than the land terrestrial platform. Earlier we have terrestrial platform, now we have a space platform. Now also non-invasive or what you call remotely sensed data collections that has come, and also point data collection and upscaling technique, particularly use of AI and ML technique has come. And similarly, the land resource management and the farming has become then enabling a precious resource management, because we cannot afford to waste our resources. I said 1.4 lakh crore we are spending on import subsidy alone for fertilizers. So, and similarly for globally, the growth of organic farming and integrated pest management and tremendous change has come in the case of chemicals that we use it in our environment. User friendly, environmental friendly, we have to use it. So agronomy practices has to change accordingly. Then globally now we are talking about much stronger than earlier, that environmental sustainability focusing on status on carbon footprint reduction, environmental reduction, and also greenhouse gas footprints, then biodiversity preservation, then ecosystem services also, because this agriculture provides ecosystem services as well, that we have to coming days we have to quantify. When you go for any specific agronomic practice, you should also quantify not only yield but also what is the services the agronomic practices provide. Particularly now we are talking about improved water use efficiency, certainly it reduces the greenhouse gas emission. Improved nitrogen use efficiency, it reduces the greenhouse gas emission. That much service the farmer is providing globally, that we have to quantify. So that way your agriculture will be moving. So these are all the some changing situations in each and every method, that irrigations now drip sprinkler, now we became computerized sensor based release system like crop genetics, resource soil management also, pest and disease control, then other sustainable practices now commercial. Once organic farming carbon is subsistence level, now it is a globally accepted practice, and also globally recognized practice has come, and people are looking for standards into how to conserve soil carbon and how to improve conservation agriculture practices, organic farming. Now people are looking for standards so that they can go for trading or marketing. So subsistence has converted into a tradable commodity. That's what has changed in our system. Now the opportunities for a student, either you can look for job in government or other sector, or you can start your own service sector. That's very imminent in the coming days. Then you can become an entrepreneur, particularly laboratories, accredited laboratories. You should know the standard. That's why I said you should know the basic. You should know the standard where the global research on land management is heading for. Then you can start successful entrepreneur. Now you see Netherlands, one of the successful country in the world. They don't have any land at all. Most part of the land is below the sea surface, but they have developed a global standard. They develop techniques and methodologies and sensor which are globally acclimatized. So they train like their manpower towards the service sector. There is a huge scope is there. And similarly, it will be high tech early adopter. Farmers will be there. They will be looking for information, and that is the way your commercial agriculture will go. So to conclude, the knowledge and hard work has put into this our country into a resource management. Now time has come, we have to change and go for high-tech management of our land resources. The user and demand has changed, and the country's perspective has changed. There is an increased expectation to reduce the input cost and also increase our export and also meet our food grain production. The technology should evolve and it creates a new opportunities, but not only the challenges. Also, the agronomic practices has undergone tremendous changes, particularly from subsistence level to intensive system, then farm level centric to global resource management. So now agronomy for global resource management has to evolve. Now advent of AI and digital globe as support and enslave us now. Everybody wants to everything on computer, everything on the mobile based system. But whether we are rationally thinking, whether it is enslaving us, that needs to be discussed, because the farmer's choice will be different from AI based selection. So the cultural element is there, that always we have to respect into the while evolving a system. Then human understanding of science, environment, and emerging need has to be there. That's what we discussed about land degradation, neutrality, then emerging global problem. Until otherwise we address our food security in line with the emerging global issues and climate and environment, we are going to land in a problem. So all the to my concluding remark would be, whatever land resources we have put and we have managed it we need to improve our institutional or individual level, the way we look into the resources, and also we should remain relevant at country's growth perspective, and also we should address the farmer. So societal need we have to address. That is very, very important. It is not only the technology and also the precise management. We should not create any environmental issues for the society. And we should also address the food security at farmers and farm level before we think of global issues. So all go simultaneously. So yeah, rational thinking has to evolve in spite of development at very fast space in information and communication technology. So let us hope that all the things that happen, you should improve your understanding of the science development. Also, we should keep in mind the social demand, as well as the country level perspective, and also relevant. Then only in the future years, land resource managers, I mean all natural resource manager, will be relevant in the context of changing need. So this is what going to happen, and let it be relevant through the society as well as ourselves, so that our research and other effort will benefit the society. So with this, thank you very much for these opportunities. I have taken good number of time, quite a good bit of time for you. Thank you, sir. Thank you all.
Thank you, sir. Thank you for your thought-provoking lecture. And now it's open for discussion. If any clarifications